Hi everyone. So this video lesson is about how to determine whether a molecule is polar or not. So we're going to write a note about molecule polarity. Okay. So one of the first things that we need or that are required for us to determine molecule polarity is we need to be able to draw the Lewis structure of our molecule. So we need to draw a Lewis diagram. The next thing that we're going to need is we need to know bond polarity. So we need to know whether we have nonpolar bonds, polar bonds, or maybe even ionic bonds. So we need to know that bond polarity. Okay. The third thing that we need to know is going to be the symmetry. And that's a new topic, and so we're going to talk about that today. And then we can determine whether our molecule is going to be polar or nonpolar, or whether maybe our molecule happens to be ionic. Okay, so we're going to learn this by using some examples. So the first example that we're going to start with is going to be HCl. So the formula is HCl. So when we draw our Lewis structure, we end up with a single bond between our hydrogen and our chlorine. Okay, we're going to determine the difference in electronegativity so that we can figure out the bond polarity. So the difference between hydrogen and chlorine, if we look at our periodic table, hydrogen is 2.1, chlorine is 3, so our difference is 0.9. And we know about bond polarity, that means that we have a polar bond. So since our bond is polar, we also know that we can put our partial charges onto our Lewis diagram. So that means that our chlorine is partially negative because it has a higher electronegativity. And then our hydrogen is going to be partially positive. Okay, so we drew the Lewis diagram. Now we know the bond polarity. Now we want to figure out whether this molecule is symmetrical or not. Okay, so in order to do that, the first thing that we want is to figure out what the shape of the molecule actually is. Since this molecule has only 2 atoms, it is automatically going to be a linear shape. Okay, there is no other option when there are only 2 atoms in the molecule. The molecule will always be linear if there is only 2 atoms in the molecule. So it is a linear shape. Okay, this linear shape happens to be non-symmetrical. Okay, right now I want you to trust me about symmetry, and I'm going to give you a list for symmetry, and we're going to talk more about what symmetry is. But for now, I just want you to trust me that linear in this instance is going to be non-symmetrical. So it's a non-symmetrical molecule. And so that's going to mean that we are dealing with a polar molecule. Okay, so let's just go through the steps that we used to determine whether this was a polar molecule. So the first thing we did is we drew this Lewis diagram. Okay, then we figured out whether our bond was nonpolar, polar, or ionic. So we determined we had a polar bond. We figured out what the shape of the molecule was, so it was a linear shape. And we knew that our linear shape is non-symmetrical. And so it's going to be a polar molecule. Okay, so the big things that are going on there is that because we have this polar bond and we have a non-symmetrical shape, that's how we know we ended up with a polar molecule. Okay, so we had a polar bond but a non-symmetrical shape, so we ended up with a polar molecule. All right, let's try another example. So let's try H2O. Now we already really know what our H2O molecule looks like. So we can draw its Lewis diagram pretty easily. And we also know its difference in electronegativity. Oxygen we know is 3.5, and hydrogen is 2.1. And so our difference between oxygen and hydrogen is 1.4, which means we're dealing with polar bonds here again. Okay. And if we look at the shape for our water molecule, the shape for our water molecule is going to be bent because it's got those two bonds to the hydrogens, but then there's also those two non-bonding pairs. And so the shape, remember, just go back to our lesson about shapes if you're not sure why this was a bent shape. Since we know we have polar bonds, the oxygen is partially negative, our hydrogens are partially positive. Okay, and bent shapes are non-symmetrical as well. So since we're dealing with having polar bonds, but a non-symmetrical shape, again here with water, we're dealing with a polar molecule. So again, we had our polar bonds, but we had a non-symmetrical shape. So we're dealing with a polar molecule in the case of H2O. All right, let's try one more example, and then we're going to talk about a few rules, and we'll try a couple more examples after that. So one more example we're going to look at is going to be CCl4. So this is a carbon with 4 chlorines. So our carbon with 4 chlorines. And each of our chlorines has those 6 non-bonding electrons. All right. And if we determine the difference in electronegativity between carbon and chlorine, carbon is 2.5, chlorine is 3. So we're sitting at a difference of 0.5, which means, again, we have polar bonds. Okay, and so we're going to draw in our partial charges. The chlorine is more electronegative, so it's going to get the partial negative. And then our carbon is partially positive. Okay. And when we're looking at the shape for this molecule, we've got 4 bonds coming out of our carbon here. And so this is a tetrahedral. So this is a tetrahedral shape. Tetrahedral happens to be a symmetrical shape. And so what's going to happen here is that is going to mean that our molecule is actually nonpolar. So the way that that worked out is we had polar bonds, but we had a symmetrical shape now. So we are ending up with a nonpolar molecule. Okay, so we had polar bonds, but a symmetrical shape. And so now we're ending up with this nonpolar molecule. So I just want to talk about a couple of the rules here in terms of symmetry. So our symmetrical shapes okay, there's a little bit of a list of them. Our symmetrical shapes, so the first one is trigonal planar, as well as tetrahedral, the trigonal bipyramid, the octahedral, the square planar, and the last one is linear, but this one is a tricky one, so we're going to add something to it. So the linear shape that we're talking about here is not linear when there's only 2 things. It's actually more looking at something that would look more like CO2, where there is a central atom, so that would be the carbon, and then 2 surrounding atoms. And so that's the linear shape that we're talking about that's going to be symmetrical. Okay. All the other shapes are non-symmetrical. Okay, so all others are non-symmetrical. And as well, these shapes are only symmetrical if the bonds are all equal. Okay, so even though trigonal planar, tetrahedral, trigonal bipyramid, octahedral, square planar, and linear are symmetrical shapes, those shapes are only symmetrical as long as the bonds are all the same. Okay, this is going to be the end of video number 1, and so I'm going to continue this in video number 2.